Year 10, welcome to this week of science, our last week of science before a nice well-earned break for half term. We've got a couple of lessons this week as normal, first looking at antibiotic resistance and then moving on slightly to look at non-communicable diseases. So we'll start as ever with our start questions, the first one of which is state the equation for area of a circle. Okay. Second one, how do antivirals stop a viral infection? What is it that they do to stop a virus, make you feel better? So thinking back to the start of last week. 3, what is it that antibodies lock onto on pathogens? What is it that they do to lock onto pathogens? What specific bit is it that they grab onto? 4, state the equation for kinetic energy, thinking back to our physics. 5, going back to chemistry, a solution turns dark red when you add universal indicator to it. Does this mean that it's an acid, alkaline, neutral? Which one is it? Okay. And then finally, explain the shape of the graph of temperature versus enzyme activity. So thinking way back to the beginning of biology, what does that graph look like? And explain that shape, explain why it looks that way, explain what's happening to the enzyme at each point. Okay, that's a classic exam question worth a good few marks. Okay, so that first question, area of a circle, it's pi r squared, important for maths, important for science. We looked at it last lesson. Antivirals work by stopping a virus multiplying. So instead of killing that virus, it just stops it reproducing, which eventually leads to it dying. Antibodies lock onto the antigens of a pathogen. Okay, that's the spiky bit around the outside that makes you sick. Kinetic energy is a half times mass times velocity squared. So you can think of kinetic energy as how much something hurts when it hits you, which is very much dependent on the mass and the velocity of that object. And if a solution turns red with universal indicator, it must mean it's an acid. And finally, that shape of the graph, well, it goes up at the beginning because increasing temperature increases enzyme activity, makes your enzymes work better. It reaches an optimum, a peak, and then after that peak, temperature starts to get beyond the optimum, and so enzymes begin to denature, activity decreases until eventually it flattens out because all those enzymes are denatured and therefore they no longer work because substrates can no longer fit inside that active site. Okay, good. So today we're going to look at antibiotic resistance, and previously when I've taught this lesson in earlier in the year or earlier in last year, I always start by showing this article here about how the Chief Medical Officer of the UK said that antibiotic resistance was the greatest threat to human health, to the future of the planet. Obviously, I imagine that opinion has been slightly changed due to recent events, but antibiotic resistance is definitely something that's a bit scary for us, or should be a bit scary for us, and something that we should all be doing our little bit to work against and to try and reduce. And it's something that, whether you know it or not, you will have already played a role in reducing, because if you've ever gone to the doctors and you've been feeling ill, you've been feeling poorly, your doctor's reluctance to possibly prescribe you antibiotics will be to do with dealing with antibiotic resistance. And if you have ever taken antibiotics, like these here, you will notice on the back or on the label, it will say, ensure you take the full course. And hopefully you have all taken that advice and you take the full course of antibiotics, because that's incredibly important in countering the effect of antibiotic resistant bacteria. Okay, and that's where we're going to start today, looking at what antibiotic resistant bacteria is and why taking the full course of antibiotics counters that and reduces that effect. So I'll head over to the slide now and talk you through that. Okay?
Exactly what antibiotic resistance is. It's worth just reminding ourselves of what antibiotics are and what we use them to counter. So we looked at antimicrobials last lesson, and general medicines the lesson before that. And antibiotics are used to kill bacteria, and when you are prescribed them by a doctor, it's because they think that your disease, the pathogen that's making you ill, is caused by a bacterial infection. And so antibiotics are a chemical that goes into your body and kills that bacteria in exactly the same way that other antimicrobials kill different types of pathogens. It's no real different to using Dettol or bleach to kill pathogens. It's just that this is specific for your body, specific to fight different pathogens. Okay, and because we use antibiotics a lot, bacteria starts to become resistant to it. Just in the same way that if you drink lots of alcohol, you become resistant to it and you don't get drunk so easily, bacteria becomes resistant to antibiotics. Okay, and the example that's often in the news that you hear a lot about, which you might well have heard of, is MRSA. This is a type of bacteria that has become resistant, and it is relatively common. It doesn't necessarily cause any issues at all. Lots of us might have this bacteria on us right now, but if you become infected with it, as in you've got a cut or you have an operation and you become infected with this particular bacteria, it's very difficult to treat because it is resistant to the medicines that we would normally use. So our normal antibiotics don't work as well on it, and that means that it can cause serious complications. And this is why hospitals in particular worry about MRSA and check whether you might have been exposed to it beforehand, because if it gets into a hospital, it can spread very rapidly and cause lots of problems. Okay, so whenever you take antibiotics, it is mega important to take the full course in order to reduce antibiotic resistance in bacteria. So bacteria, it's just a living organism, and it evolves and it breeds like anything else. And as a result of that, some are naturally just more resistant to antibiotics. Some, when you take those antibiotics, put up more of a fight. And that's just through luck, through natural selection. It means that they are better able to fight off those antibiotics. But if you keep taking the full course, you take them all the way to the end, even when you start to feel better, you will eventually kill those antibiotics because kill those bacteria, because those antibiotics are strong enough to do that. And the course, the prescription, the dose is designed with that in mind. It's designed to kill absolutely every last one of those bacteria within you. If you don't take the full course because you stop when you feel better and you think, well, I don't need to worry about that anymore, I want to be able to drink again, or they're making me feel sick, or whatever your reason for stopping those antibiotics, it will leave behind just those strongest bacteria, just the ones that were naturally resistant anyway. And because you've left them there, over time, they multiply and the bacteria become stronger because all the weak ones were killed off. Only the strongest survive, only the strongest multiply, and so all the bacteria is now somewhat resistant to those antibiotics. And the first time that happens, it won't be a massive problem, but over years and years and years of us using antibiotics, this has become more and more of a problem. And in this country now, it's quite hard to get antibiotics. Certainly for me, if I go to the doctor, I really need to fight to get them because I'm a man, naturally reasonably healthy. I'm unlikely to die of any normal bacterial infection, and so they would rather my natural immune system fought it off rather than risking over prescribing antibiotics. but a few years ago when I was younger, it was much easier to get antibiotics. And if you go to certain countries in Europe, other countries in the rest of the world, you can just get them over the counter. And so this has become a much bigger problem because we use too many antibiotics, and so bacteria becomes more resistant. And in the same way, normally using things like hand gels, using things like surface cleaners, all builds up antibiotic resistance as well, or at least resistance in bacteria, because you're exposing them to things that could that are trying to kill them all the time, and you're promoting the strongest by not necessarily killing them all. However, at the moment, it's very important that we clean all our surfaces and wash our hands lots, because the threat of resistant bacteria is much less than the threat of the coronavirus, which is right here with us now. Okay, so I'll cross over and look at a little analogy for how antibiotic resistance forms by having a look at my front garden. Okay, so this is my weed-filled front garden, and last summer I did a really good job of clearing all these weeds away, my shoes to prove it's me, except I left a few weeds behind, a few that I couldn't quite be bothered to get rid of, and now since it's rained, it's been sunny again, all these weeds have returned. Had I done a better job to begin with, this wouldn't be a problem now. Now I've got a big task getting rid of all of this. Okay, this is what antibiotic resistance is. Let's go inside. So now we can look at this stage by stage of how antibiotic resistance bacteria comes about, using these lovely pictures that I drew myself. So the first stage is when you're feeling ill, you go to the doctor, you are diagnosed with a bacterial infection and are prescribed antibiotics. So this mainly starts with that process of taking antibiotics. And those antibiotics do their job. They kill lots of the bacteria, which is exactly why we want them. It's why antibiotics are so important. Antibiotics are one of the greatest discoveries in terms of saving lives. They're good. It's just that we use them a bit too much. And some bacteria are naturally resistant. So this guy here, just through nature, is resistant. All the other ones have died. And because we've killed loads of those bacteria, we feel better, we are cured, we're happy, and so perhaps we stop taking those antibiotics, which isn't what we should do, but it's what lots of us do. And because we stop taking those antibiotics, that resistant bacteria is allowed to stick around, and it's allowed to multiply, and now they're all resistant. All the unresistant ones died off, and we're left with all these more powerful, more resistant bacteria. And it could be that then they return within you and you get sick again and antibiotics don't work. But what's more likely to happen is you pass on that bacteria in some way. And it can be through a few people. It might not be immediately that you pass it on. It could be you touch a surface, someone else picks it up. It can take a little while until it gets into someone else and infects someone else. When that does happen, the antibiotics that you use to help you won't be effective on them, because it's that resistant strain that remains, and so your antibiotics are no good. And it might be that they still work a bit and you just need to take a lot more of them, but more likely the antibiotics just don't work at all. And certainly as a few generations of people do this, and it happens more than once, the resistance just builds up and up and up. And it's why we're at this point now where we have things like MRSA, which are very hard to treat because they really are very resistant. Okay, good. Okay, so hopefully you now have a nice understanding of how antibiotic resistant bacteria forms and why it's important that we stop that and do what we can to prevent this bacteria forming. Happily though, there's a few things that we can all do, as well as a few things that hospitals and scientists are doing to combat the effect as well. And really it's the things that we can do, the first couple of steps on this list that we're about to look at, that are the most important, and happily they're things that we can all do with relative ease. So firstly, we can try to take fewer antibiotics, and doctors are less likely to prescribe them now, but we can all make a bit of effort in this as well and try to avoid going to the doctor, try to avoid asking for antibiotics when we're not feeling well. And of course, there are times when you need them and you should absolutely take them then, but if you can sort of suffer a little bit and get through an illness on your own, let your body look after you, that's better. It means that we're able to save these antibiotics for older people, vulnerable people that need them the most, and they'll still be there for us should we need them, and means we get less of this resistant bacteria. And then equally, when you do get prescribed those antibiotics, it's really, really important that we all take the full course. It's really easy to fall into the trap of thinking, well, I feel better now, I'm not going to bother taking those anymore because it's a pain to remember to take them, or they make you feel a bit rough, or a load of other reasons that you might not want to take them. But it's important you're doing something for the greater good and has a material effect on the world by just making sure you take the full course. In terms of other things that healthcare professionals do, well, hospitals are cleaned really regularly. They are anyway, but they're specifically cleaned with this in mind so that this resistant bacteria doesn't get into hospitals, because it's much, much more of a problem when someone is already ill or somebody is already slightly vulnerable. So this bacteria is particularly a problem for post-op patients. If that bacteria gets into them during the operation, they are weakened by the operation anyway, and it can really get hold, and it's very difficult to treat because it's resistant to the regular treatments, and so it can have a nasty effect. Broad spectrum antibiotics, you might have heard of this on medical programs. It just means that it sort of attacks everything every time a bacteria, and so it can form lots of different types of resistant bacteria, which isn't good. And then these last two, we are trying to develop new antibiotics, which is only really a short-term solution, because this problem with resistant bacteria will still be there. It will just become resistant to these new antibiotics eventually, but it does at least kick the problem into the long grass a little. And then vaccines eliminate the need for these antibiotics, because it means that we can just boost our immunity to them in the first place. Okay, so we'll look at a little exam question that brings all that together. Antibiotic resistant bacteria can cause infection outbreaks in hospitals. Strict hygiene procedures are enforced to try to restrict the spread. Explain how antibiotic resistance bacteria develops and why they are such a problem in hospitals. Describe some steps which are being taken to try and prevent the development of resistant strains. So this is a nice 6-mark question. It's really designed to separate sort of your middle ground students to the top students. We're going through this. You're all going to be top students. You'll all be happy with how to answer this question. Make sure with these that you're talking about both parts, explain and then describe. So explain, we need to talk a bit of science, and then describe is a little bit simpler. So we'll start with the tough bit, and we can say some bacteria is naturally resistant to antibiotics. Show that you understand that some bacteria is always going to fight back, but what causes the problem is that these bacteria won't be killed when you take those antibiotics, so they'll stick around, and then it's really what we do which determines what happens next. If we don't take the full course, they will survive, and then once they survive, they are stood around wondering what to do. Eventually they multiply and you get many more resistant bacteria. And you could point out here that over years they will all become resistant. If everyone did this all the time, there would be lots and lots of resistant bacteria. And it's taken years for this to be a problem. We've had antibiotics for a long time, and it's only really the last few years that this has become more of an issue. And then you could say here why this is such a problem in hospitals. Hospitals treat vulnerable people. They treat people that are already sick, they've had operations, and so they are more prone, more at risk to infections anyway, and a resistant infection and resistant bacteria is going to be more of a problem. This is why nowadays if you give birth in a hospital, they try and get you out as quickly as possible, because things like MRSA, things like resistant bacteria are greater risk than the small risk of going home a little early. The things we can do to prevent it, we make sure we take the full course and we try to take as few antibiotics as possible. So questions like this, absolutely everyone can state some of these steps to prevent the development. So if you're unhappy with this explain bit, you find it a little bit confusing, go for the simple steps. It's caused by not taking the full course. You can prevent it by taking the full course. You don't always need to aim for all 6 marks on these questions. Make sure you get the ones that you do know and don't get freaked out if you're not 100% sure on the answer. Okay, so this question appears in your assignment, so you should all be getting 6 marks on that one at the very least. Hope you're all well. Bye-bye.